Recently, I was up for a refresh of my Cisco laptop, and I've been running Windows for so long. If anybody has seen me give these webinars in the past, when I was doing automation, you noticed that I was using Windows 11 to do all of that. That machine was slowing down so much that I decided that I'm going to go ahead and switch over to Mac OS. And in doing so, I have to reset everything back up for my whole automation setup and from the get-go. And it occurred to me that that would be a good experience to capture to show people how to do that. But why just show you how to set up and configure on Mac OS when I can show you Mac, Windows, and Linux all through the same process and experience, right? And in thinking about that, Thomas and I have both given a bunch of webinars on automation and APIs. And we've all tried to give hints of how to set up and how to get your different workstations set up correctly so that you can do this, but we've never been comprehensive from start to finish in any one of our webinars. So I really wanted to spend some time today in being able to do that. Hopefully you can watch along, identify with what I'm doing, understand where I'm going, and by the end of this, you should be able to create your own playbook, or at least copy my GitHub repository and run your own playbook right from your workstation in about 15-20 minutes. So sit back and enjoy. Hopefully this takes you to where you want to be. What really spoke to me about it is we have spent considerable time in webinar hours, honestly, to help to bring everybody into this world. And now we just want to make it bare levels basic. And the last webinar that I did on automation was the upgrading ICE in the cloud. And this webinar really meant a lot to me because I drew upon real world experiences when I was putting this one together to show the time savings that automation can bring to just upgrading ICE. And I was able to do both an 8-hour and a 16-hour, or an 8-node and a 16-node deployment in under an 8-hour shift. We were at like 6.5 hours to get these done. And it's very repeatable. So if you want to go we went from 3.2 to 3.3. If you want to go from 3.3 to 3.4, you just use the same playbooks and just change your different images that you're using to install. We did do the backup and restore version. As you see here, this is the 8-node upgrade that we did, and it was 6 hours, 22 minutes. And if you divide that by the 8 nodes, that's less than 0.8 hours per node. So the time savings here is really great. And that drove home to me what automation really means and what it's going to do and be able to provide for everybody. So I hope you get excited about the possibilities as far as that goes. So we're going to start with APIs, because without APIs, the automation doesn't work. Everything's built upon the APIs that are used within ICE. And what an API is, it's a piece of software that you use to send information. In this case, it's a code to ICE to affect a change, whether you want to create, update, or delete anything that's within ICE. You send that through an API programmatically. The APIs that we use in ICE are REST APIs, which means that they are stateless. You don't have to worry about them keeping your credentials for login information. As soon as the API goes and it's run, that information is then no longer needed and it's discarded by ICE. So it doesn't stay on that server. It's just temporal, I guess you could say, for, calling back to our posture agent, we have a temporal authentication because of this. Keeping that in mind, one of the first things that we want to do is we want to create some API admins. Now, here are a couple administrator groups that are built into ICE, the ERS admin and the ERS operator. The differences between the two of them is anyone who is a part of the ERS admin group has read-write permissions to anything within ICE APIs. Whereas the ERS operator is read-only. They can do GET requests, and we'll talk about the different type of requests later, but they can read the information from ICE, but they can't affect any chain. And the important thing to note about this is that the only role-based access that this is giving you is that if you're a part of these groups, you can read and write, or you can read only. You don't get anything more granular than that. If you're an ERS admin, you have access to all the APIs and to write using every one of those APIs. So if we take a look at the administrators that I have created, I created an API admin and API lookup admin. One's an ERS admin, ERS operator. So we have a full control and a read-only admin that we can see here. But one thing to note is a super admin is a part of every group. So super admins also have full control over your APIs. So that means your default ICE account is a super admin, and that account can be used for API. When you're creating these accounts, during that admin user creation, you can see at the bottom, that's where you choose which account you want that user to be a part of. One thing to take into mind when you're doing this is that there's no space on this account creation form for a password lifetime. So this password for all your admin users adheres to the password policy for admin users. So if you go into your password policy for admin users, go into your password policy tab and make sure that you turn this setting off. By default, we recommend this as a best practice anyway, so that your administrator password does not expire. If you're logging in through Active Directory or any other means, then your default admin user could expire without you knowing it because you're not using it. So when you're trying to do something to recover or get into the system that cannot connect to your external systems, you need to have access to that admin password. So we recommend to turn this off anyway. Having said that, we're going to talk about the method that I prefer when just using APIs, and that's using curl. What is curl? Well, that's easy. Curl is just a client URL system that lets you talk to a server by telling it which server and what data you want to send. This has been around since 1998, so it's actually one of the front runners of the whole API ecosystem. It's available to install on any system that you want to. Matter of fact, since 2018, it has been built into Windows. So all you have to do is just check the curl version through your command prompt to see if you are the latest, or if not, you can install the latest from your command prompt. With Linux and Mac OS, you do install it, but it's a single command install. It's very simple, very lightweight, actually. And once you have curl installed, we need to store some environment variables in your shell. What this allows you to do is it keeps your credentials safe. Nobody's going to read your credentials just by going through your APIs, because you're using variables that calls upon your environment instead of actually documenting them in plain text. So what I do is I name my environment variable files very simply. So for the ICE variables, I use ICE init password. That's if you're using cloud installation or zero touch provisioning, then it has an initial password that you have to change once you log into the GUI. So to have that init password as part of your environment variables is very helpful, especially when you're talking about automation and doing things to ICE prior to logging into the GUI. The other thing is you can have environment variables for your cloud host. So I have environment variables for AWS where I keep my access keys and my secret keys and all of that, so I don't expose those out to everybody when I'm doing, webinars such as this, or they do a git clone from my GitHub repository and they download all of my stuff. They don't download my credentials. Once you have these files stored in your system, you load them into your shell by simply using the source command that you see here, and that will load them into your shells. And I'm going to be using this. You'll see how it's actually used in the terminal. The other thing is, it's actually important to note that when you're doing APIs, when you're doing automation, anything that you're going to have something that you want to be repeatable, you're going to want to save that API into a format that's easy for you to read and understand. A simple text editor is great, especially for APIs, just because that's really all it is text on your screen that you're going to send to affect a change. My favorite would be the VS Code from Microsoft. And the reason for that is I can use that both for APIs, my automation playbooks, and a lot of other different things. I actually use the Microsoft VS Code to create and store my environment variables in a different folder away from my project folders. So let's take a look at curl real quick. And I'm going to bring up my terminal. One thing about the VS Code, I use Codium, which is an open source version of VS Code, is that you can use either one of them straight from your terminal. It'll actually pull up the graphic interface just by typing in the name. And then I use a period to say I only use this present working directory, right? So let's go ahead and we're going to move into our labs webinars folder. I'm going to open up my Codium from the labs webinars folder. It helps if you spell it correctly. And you see it opens right up here. Okay. So one of the things I want to do is to have all of my APIs and my playbooks and everything I'm going to be doing today, I want it to show up in this folder. It currently doesn't show up there. And the reason it doesn't is because I have to download everything that I have in my repository to this folder so that it will show up. The way that you do that is very simple. We're going to go into my GitHub repository. And the way that we access the GitHub repository from our terminal is that we just do a git clone. And this is going to take everything that's in my GitHub for this webinar, and it's going to copy it into this folder. Now that we've done that, you can see that we have a new folder here, and we're going to move into that folder. So now if we go into Codium, you can see that we have populated all of these different folders. And we're going to talk about the APIs. So in using curl, which is a command line utility, I've got all these APIs listed out here. And you can see I've got these dash lines separating each of them. The easiest way to run APIs, if you're doing a string of APIs back to back, is to open up a terminal window straight inside your VS Code or Codium. What I like is to have, where am I going to do this? I'm going to do my panel position at the right, okay? So what that does is it puts my terminal over to the right. So I have a split screen of my APIs and then of my terminal. So I don't have to go back from screen to screen to decide or to copy and then to paste. So I'm going to create a network device within ICE real quick. All right. First thing I do want to do is I want to show you that if we go to our network devices, we don't have any within ICE at all right now. So let's jump back into VSCode. We're going to copy this, then we'll paste it into our terminal, and we're going to get an error. See here, we have an error here. It says we can't talk to that. What the heck is this even? And the reason for that is we did not source our environment variables. Remember how I told you that was a very important item that we need to do? So if we take a look at our environment variables, oh, look at that. We have to source it, tell it that it's going to be a source for our environment. The great thing about live demos is you can see that I type quickly without even worrying about what I'm typing, so that it doesn't always come out great. So now that I've done that, I can check my environment. I'm going to search just for my ICE variables, right? Now that's not going to come up with anything. And the reason is the environment that I just loaded is for my AWS and for my actual ICE credentials and all of that. I'm going to now source the environment variables for this webinar so you can see what I mean about loading them into your environment. Now, if we do the environment search on ICE, you can see I have these different environment variables here that can be called upon and used within our APIs. Why is this important? Why does it matter here? Because if you look here, we're using the $, then ICE REST username, which would be the ICE REST username in my actual variables. And these are the variables. This is how we call a variable when we're in CLI, is you use that $ and then the variable name. So now if we copy this, we're going to paste it here in our terminal. Now you're going to see that we have a 200. Anything that you get as a response code in the 200 range is a success. So that means if we go over into ICE and we refresh our network device groups, you can see that we now have our network device. Oh, great. We created a network device. What is it and how can I address it for future APIs? Well, we can see what it is by doing a get command. And get is just saying, send me the information that you have for this device. And you can see with the response, we get the ID, the test device, or the name, the description, and the relevant link to the endpoint here. Since APIs and the ERS APIs that we are using are based upon ID, we're going to want to copy this ID here so that when we go and get the specific network device, you see how it says you need a device ID at the end of the URL. Come in here, we're going to do a replace. We're going to replace that device ID with the actual device ID, right? We're going to replace all of those within the document. There's actually 4 of them that we're using for the different commands here. So now if we use that device ID, go back over our terminal, you see we get a bit more information with the IP address and the locations and the different groups that it belongs to. So now we have more information. Let's update that device. We're going to update the device name and the password. Now I'm updating 2 fields here and I'm sending all of this information. You see everything here in the data line and below. with ERS, if you're doing a put command, which means an update command, if you don't send everything that's already populated, then the system thinks that you don't want that to be populated anymore, so it removes that information. So you keep everything that's already been populated, you just add your changes into it. So now that we've added those changes into it, including the name and the password, and that's all we did was the name and the password. We can see that the results show us only that which has changed. If we go into ICE again, you can see that from test device, we've changed it to put device because we used the put request to change that command or change that device name. In ICE 3.2, we actually allowed the use of the patch command. The great thing about the patch command is to change your devices. If you use patch, you only have to send the name or the attributes that you are changing. So in this case, we're going to change the name, the description, and the radius shared secret by sending only those lines. And it didn't like that because I got a 404 command. Everybody knows what 404 means. That means can't be found. So that's a fun one, isn't it? Looking through the rest of the response, it's not jumping out at me to be real apparent. My URL is consistent with the URL of the patch. Oh, no, it's not. No, it's not. See here, I don't have network device. So my URL was different. So let's add that in here and we'll try this again. See, live demos are fun, aren't they? You get to go with me through all the troubleshooting. All right, now that we've done that, you can see that we've got a better error code here, error code of 200, which means successful. However, when we did the put command, our response was only what has changed. When we do the patch command, where we only send what we want changed, it sends us everything back, right? One thing to take note of, though, when you're doing the patch command, is that your response does not hide the password. The password is sent in plain text. So just be aware of that. And then if we go back into ICE, you can see that we've updated to a patch test and our description has changed as well. All right, well, we no longer need this device, so I'm going to go ahead and just delete it. Oh, not select all. There we go. That's paid. All right, 204. All right, remember 200 range is successful. ICE tells us that it was successful because it's no longer there. So great. That is curl. I talked about a lot of different things. You saw a lot of different things within the APIs that I was sending. So now that you've seen what we're sending, let's break it down so you can understand what we sent and why we sent it. There are 4 elements of an API that need to be sent. And let's talk about what those 4 are. First, we're going to talk about everything in order that you see them on the screen. So let's jump into the headers. What you see here is this long line is actually what an API request looks like when you send it to the server. It's just a single line of all this text. What we do, what I hope that you do, is you can break these lines in your command prompt, your CLI, by adding that space and backslash at the end. That allows you to start a new line and make everything readable and on the same screen so that you don't have to scroll left or right to see what you're trying to send. It puts it all right on the screen for you. You want that backslash to be the last character on each line. If you have a trailing space, then it's going to not run. So just end with that backslash, and go down and create your new lines. Then we have the different options that we can send when we're sending the request. The two that I want to talk about on the first line is insecure, means that we're not checking certificates. We're not validating certificates when we send this. And location means we're going to follow all the redirects that the server might send us on to get to the location that we want the API to be running. The header lines means that I'm going to send the request in JSON format, and I would like you to send me JSON format back. And you saw that when we got our responses back from ICE, they were in the JSON format with all the squiggly lines and the indentations and everything. You can see that we're using our environment variables for the username and password. And then the HTTP method and our endpoint URL. So we're going to talk about those as well. Let's talk about the HTTP method real quick. Well, before that, got ahead of myself. When we're talking about, I sent the request in, I'm sending my request in JSON. I want it back in JSON. The other format could be XML. And there's a reason that we prefer JSON. Here's XML, here's what it looks like. And you can see, if you focus and look deeply into this, you can see that it does contain the information we want, but it's hard to see that information because it's hidden in between all these angle brackets. With JSON, it's pretty much a list from top down that you can read just by identifying the text that is within. So JSON is a lot easier to read and to parse when you're looking at it, which means it's easier to write as well. All right, now we're going to talk about the HTTP request method. I was talking about the post and the put and the patch methods while we were updating our network device. And really, that's what they mean. There are 5 different methods that we can use here. And the only thing you have to do to change them is change this word right here. And they can be any one of these methods that you put here. Just remember that anything that is not a get or a delete requires a body. With a get or a delete, all you need is this endpoint URL to affect the change. That endpoint URL, like I said, that was the one that tripped me up. I didn't have the network device in the URL there. Let's talk about that a little bit more. For the endpoint URI, we have these different elements to that URI. Every URL is a URI, so you can use them interchangeably as far as that goes. We're not going to be using the queries or the fragments, but I want to talk about the fragments just because we'd love to use fragments in other things. Web pages. We have our iceberg that has a list of all of our resources for ICE on our Cisco communities. And if you use a hashtag and then API, you will see the section of that document that has all of the resources for ICE APIs that we can find and put together right in one single place for you to get to easily. But we're not going to be talking about fragments as far as the APIs go. We're going to talk about the actual URL that we're going to use. First, of course, you have your server name. How am I going to talk to it? I told you they are HTTP methods, your get and your put and your patch and all of that. They're HTTP methods. So, of course, the URL is going to be an HTTPS URL. Then you have your fully qualified domain name and whatever port that you want to talk. Then you have your endpoint path. This is the rest of what you want. That resource that you see bold would be my network device that I had left off of my then your query parameters if you're going to be sending a query. We're not going to focus on queries because we don't do a lot of queries with, I don't do a lot of queries with the APIs or the automation that we're going to be showing today. When you're talking about a base URL, when somebody says, what's your API base URL? It's everything up to that resource. So everything up to network device would have been that base URL for the API. So all I had was the base URL. That's why the response came back and said, I don't know what you're talking about because you don't have your resource listed. So once we added that resource, we were able to go ahead and address the network device and do what we wanted to and patch that with the information we wanted to. Now, with the different roles of APIs that we have within ICE, we have different ports. You see our ERS APIs talk over port 9060. Our MNT APIs are 443. PXGrid APIs are port 8910. With ICE 3.1, we actually added another API dictionary called OpenAPI, and that talks over port 443 as well. To be able to talk to the ICE server, to let that server know what exactly you're talking to, you have to address the correct port. We'll talk about those ports in just a little bit. First, I want to continue on with the API request and talk about that request body. Everything that we sent, all the descriptions, the names, the IP address, are keys and values. You have a key to your left and you have your value to your right. My IP address is a key. The value is 10.10.10.5 or whatever. So everything we do is a key value. Now, the different value types that you can use outside of the key are shown here. I've color-coded these so that you could see the differences when we show the object down below. But what you want to remember is that a string can have spaces in it. It can have multiple decimal points in numbers, but you have to wrap a string in those double quotes. That's how you're telling the ICE that the API coming in is a string and to treat it as a free-form text. A list can contain numbers, strings, Boolean operators, or just a none value, the nothing that you see up above. But a list has to be enclosed in what you see the angle brackets here, or the brackets, not angle, but the brackets here. And that is what denotes a list in JSON format. So ICE is going to be understanding what that list is and where it's coming from. For the object, we have all these different key value pairs here, but you see how it's wrapped in those squiggly brackets. That's denoting that this is an object in JSON notation. And we'll talk about that. Turn those off. We'll talk about that when we talk about this full request body that we have here. This is the API that I used to send those the put, patch, and all those APIs. If we move forward here, we're going to talk just about this body. You can see that everything's wrapped in those squiggly brackets, which means that is the object. The main object, everything is wrapped in that first squiggly bracket. So from network device all the way down, that is your main object. Network device has its own object with the list of key value pairs here. And you can see how all the other elements within the value types are shown with the different colors here, whether they're inside those objects, whether they're inside the lists as well. Hopefully this helps to bring that home so that it's easier to understand. As far as APIs go and what you can do with ICE, this is a list of all the current APIs that are available to you within ICE. So just about anything that you want to do within ICE, you can do it through API. All right. Before I go into anything else about APIs here, I want to talk about why you see us posting a lot. If you're a part of the ICE bar, when we're doing webinars, you see us posting full screenshots like this. And the reason is, if you take a look at the top bar, you'll see that we have the main menu that we choose. Then we choose the settings menu over here on the next bar, and then API settings. What that tells you is if you go to administration, system settings, API settings, you get to this page. And that's why we do the full page screenshots like this for you guys. All right. If we scroll down here, you're going to see the section on the API gateway. We introduced this API gateway in ICE 3.1 when we introduced the OpenAPIs. What this allows us to do is the API gateway is another service that runs on your ICE node. And you can choose any ICE node in your deployment to be your API gateway. All your APIs are sent to port 443. The API gateway's job is then to send your ERS APIs to port 9060 on whichever host that you're sending that ERS API to, or port 443 for your OpenAPI, your M&T APIs, your secondary M&T APIs, whatever. So if you remember this whole list here, you're now just addressing these through port 443. PX Grid APIs are different, and they're not actually a part of the API gateway. So now all you have to do is just send your URL. You don't even have to address the port number, because if you send HTTPS, the default port is 443, and you can just send that straight into your API gateway. Makes it a lot easier for you guys. Now, if we go back to this page, if we go to the API Service Settings tab, you can see this is where you enable both the ERS and the OpenAPIs so you can address them. And with that, I want to show you a quick way to test out some APIs if you want to use some of the OpenAPIs that are available within ICE. We actually have an interface built into ICE where you can send any of these APIs in the categories that you see here in this dropdown. You notice this is not as big a list as I showed you before, because these are only the open APIs. These are not the ERS or M&T APIs. These are only the open APIs. But I want to go in and show you how the Swagger interface is used. If we go over here into our administration system settings, our API settings, you'll see right here on this API settings page, we have these hyperlinks. One is for the OpenAPI Swagger interface. One is for the ERS API SDK interface. Well, if we choose the Swagger interface hyperlink, we get this page. And you can choose your different API definitions here. So we're going to look at repository. If you expand that, you can see we have these different available APIs for repositories. You wanted to see what repositories you have, you can actually see this. You have a try it out button. So you can do this get command right on your repository. It shows you what the curl request is sent. The -X, if you remember, is the request, and then -H is the header. So you want to tell ICE that you're sending JSON. Then your response is you got a 200 code, which is okay. That's a successful response. And it says, well, you have a repository named FTP. The protocol is FTP. Why not? I mean, like I said, I'm simple when it comes to naming stuff. The name tells me what it is. If you keep on scrolling, though, it will tell you the available codes that you have for this specific API. What can be expected? 200 means success. 401 means unauthorized. You got a username or password wrong. 403 means that you don't have access to this. You don't have the permissions to see it. 404, not found. We saw that one. You did something wrong with the URL. Check your URL and try it again. The 500 error, something went wrong on ICE side, you can try it again. You can check ICE to make sure it's configured correctly, but there's something going on with ICE when you see a 500 error. So quick, easy way to see what repositories you have. You know what? I want to create a new repository. You can do that right from here too. You can see the example here is a CD-ROM repository. So if I want to change that to, well, it doesn't really give us any parameters to use. So let's do this. We're going to do another FTP repository. We're going to call it webinar. All right, let's try. Let's see what that does. All right, so it sent the curl command. I got a code 400. Well, that means that I have some missing information, but it tells us what's missing. So server name, password, path, and username is what I need. Well, luckily, I've actually got that right here. So I'm going to take this, I'm going to copy this JSON and put that up here. I'm going to overwrite this. So I got server name, username, password, and path, right? Awesome. So now you see the curl request has everything that we need. And I still got a 400. Well, if you look, it's not just server name, it's server capital N name. You capitalize the second name, the second word in your keys. So if we come up here and we capitalize our N's in our server name and our username, this should work. So now we're sending this. You can see that we've got the right syntax here. We've got a 200. So we have a new repository. And we can check that over in ICE if we go over to maintenance and repository. You can see we have our new API test repository. But just like with our network device, I no longer need this. So I'm going to delete it. Oh, we have to try it out first. API test was the name of what we just created. So let's execute it. All right, tell it to delete. We got a 200. It was successful. Repository was successfully deleted. Check that, make sure it's not lying. It's not. So that's great. This is a good way to know what OpenAPIs are available to you for which different definitions they call it, but the different API dictionaries. So whatever you want to do with these different dictionaries, you can do that. You can see what the paths are, and you can try it out right from this interface. We do have documentation. Remember the other link I was showing you was the ERS SDK. This shows you the API documentation for all of our ERS APIs. And it goes in depth on how do you use these APIs, what are available, and it tells you the different options available to you for each one of the APIs. So it has all your values and all your value types that are listed here, so you're not guessing like we did with the OpenAPI. This actually goes through and it tells you everything that you need to know as far as that goes. So that's good to know. We have our documentation. It's in product. You don't have to search the internet. You don't have to search Cisco or communities or anything. It's in product for you to use. So now that we've done that, we're going to go back into here and we're going to talk about these HTTP response status codes. Now, the ones that we're going to get from ICE are either going to be success, a client error like you've seen what we've experienced, or server error. Server error. We saw that as well. And as far as the successful codes go with ICE, here's what they mean. If you do a curl request for a delete, a lot of times the response will be 204 because there's no content, and that's what you'll see in the response is no content. In ICE, that means object was deleted, and we saw that through the Swagger interface that we got the 204, but it said object was deleted successfully. Now for the rest of the response codes that are relevant to ICE, we have all of these listed here. If you want to see what all the response codes that are possible, we have this hyperlink at the bottom that you can visit that link, and it'll tell you all the HTTP response codes that exist, what they're for, and what they mean. All right, now we're talking about Ansible. We're going to go pretty quickly through this because you've got the API basics down. We're going to talk about what we need to do for Ansible. Like I said, I started out with Windows. Ansible is not actually compatible with Windows. You cannot install Ansible on Windows. That's why you see that I've installed the Windows subsystem for Linux. And then inside the WSL, I installed Ansible in Python. With my new laptop, I just installed VSCode, went to my macOS terminal, I installed Ansible, Python. Homebrew is my package manager, kind of like apt in Linux. So I use that for my Mac install. Like I said, to have Ansible on a Windows machine, you have to install the Windows subsystem for Linux, and you can choose whichever version that you want. They're usually Debian-based versions, and I've always used Ubuntu. The 22.04 has always done well for me, and that's what I've used. I have no problems with that whatsoever. What is Ansible? Ansible is something that makes your life easier. It's agentless, so you don't have to worry about installing anything on your servers. It's very simple. It can grow with you as both your skills and your deployments grow. So can Ansible. It's predictable. You know what it's going to do because they have specific modules doing and written just for that. If we go back to our formats for our APIs, we're talking about XML and JSON. Well, with Ansible, we're just going to get rid of XML altogether. And we're going to focus on JSON because we can still use JSON in some of our Ansible plays, but everything for Ansible is written in the YAML format. What's the YAML format? We'll talk about that later, but the big thing that we're going to discuss is YAML supports comments. So I can tell you inside my playbooks what I'm trying to do, why you can't do this, and give you descriptions of what's going on as well. And you can do that for anyone who reads your playbooks. So here's a typical Ansible task. If we go in here and we take a look at it, of course, yes, YAML stands for YAML ain't markup language. And I've got a quick reference link here that shows you how to use the different commands within Ansible. And Ansible files can either be named with a .yml or .yaml. They're treated the same. But Ansible and YAML documents all start with 3 dashes at the top. That notes that it is an Ansible document. And then your comments begin with a hashtag and a space. You have your sequence here. This is your main device. When we were looking at the JSON, that was our object. Remember, the squiggly brackets was our main object. And then we have a 2-space indent that says this object below belongs to the object network device. And then another indent would say any objects below this belongs to the lab MR46-1. And you can see we have a new sequence down here that has a new object notation for it. So all of these are objects with different lists and dictionaries attached to them. You have inline comments as well, so you can comment on the same line. Again, hashtag and space for that. So the concepts for Ansible is we're going to start with the control node. That's your machine. For me, that's my Mac OS machine now. Managed nodes are the different servers I want to talk to, whether it be web servers, Windows, ICE nodes, or even my AWS infrastructure. And then you have an inventory, which tells Ansible what host belongs to which IP address and how to talk to those hosts, whether it's through SSH or HTTP or whatever. And then you have your playbooks. Within your playbooks, you have plays, and then you have all these pre-task roles, tasks, post-tasks, and handlers. The playbook is the file, whereas the play is this section here at the top. And the play defines which managed node is being sent instructions, whether you want to gather facts or not. So gather facts gathers everything that it can about this node, whether it exists or not, right? So it's going to spend a lot of time in trying to gather these facts, whether you need it or not. So I default to no, because I don't need to know all of the facts about every host that I'm trying to do a playbook for. If you're using variables for Ansible, then you can store those in a file for just that reason. This is where you tell Ansible where that file is. If you're doing specific variables just for this play, then you can define that variable here. And if we take a look at our pre-tasks, these are meant to be run before anything else. It sets up what you need. So if you do need to get some fact about your host, you can say, I want this specific fact, but not every single thing. All right. Then you can call on rules. These are modular and can be added to any different plays that you want. Then the main actions of your playbook are the actual tasks, and these are going to be the majority of the whole play. And if we go up a bit more, you can see that at the end of this task, we have this register key, and the value is node info. We're going to register this into a node info value so we can use that later. We're going to show that result of that registered value right here, and that's going to show us the output of what we did to get this node info. Then afterward, if we have any cleanup, if we want to show any other messages after that, that's going to be our post task. And then handlers, I don't use handlers, but ICE really doesn't have a place for handlers. If you're doing different things with like Linux or whatever, you're setting up an HTTP server and you change your HTTP config, and then you want to automatically restart your HTTP daemon, then a handler can say, well, once that config is changed, then I can go ahead and restart the daemon. And that's what that is, and that works out pretty well for that, but I don't use handlers myself. Then we have the collections, modules, and plugins. Now for the collections, modules, and plugins, I'm honestly going to show you what that is, just because it's a great resource to know and to use. So we're going to go over here. I actually have this as one of my bookmarks here. I'm going to go into the Ansible Collections. I'm going to make it big so you can see it. And these are the different collections that you can use to do anything that you want to with Ansible. We're going to focus on the Cisco.ise collection. And with that, you say, all right, are there plugins? Well, ICE doesn't have any plugins. All right. The modules. All right. So there are a lot of ICE modules here. If we go all the way down, we've been talking about network devices a lot today. So I'm going to show you what I use for the network device modules. Network access, network device. All right. So we have the network device module and we have a network device info module. The info module is basically a get. All right. You just want to get the information from what you're doing. If you scroll down here, all right, I'm sorry, I did that too fast. You have your requirements. You need the Cisco.ise SDK, and you need to have Python above version 3.5. Then you have all these parameters. What happened there? I clicked it. Yeah. You have all these parameters that you can put in and fill in to send to ICE for your get. And then you have examples. You can get all your network devices by ID or by a string. Honestly, for a lot of these, you just copy this and you paste it into your Ansible playbook, change whatever variables that you have, and you're ready to go. Same thing with your network device module. If you come back here, go down the different parameters, you have all these different examples of what you can do. Now for the plugins, some plugins are actually really, really important. And my Amazon.aws has a plugin. And the reason I like the plugin here, see it says these are the plugins, but if you where to go? Yeah, plugin index. If we go down to the plugin index, where are they? All right, all the way down at the bottom of the page with the inventory plugins. And this is important so you can get a dynamic inventory of whatever you want or whatever you have within AWS. I'm going to show you that in a moment. I think it's important for you to see. These are all the Ansible collections that are available. Cisco is very Ansible friendly. We have a lot of Ansible collections out there. And if you've seen my previous webinars with Ansible, you know that I've used a lot of these different collections with my automations. Speaking of VS Code, before I get into my Ansible demonstration, these are the extensions that I use in VS Code. And this just makes everything easier. Of course, you have to have the YAML extension to support YAML in VS Code. But everything else is basically just to make it easier to read, make it format for you. And then we have this information for if you want the keyboard shortcuts. That link has it for Windows, Linux, and Mac OS. This is how you install VS Codium. You can go to visualstudio.microsoft.com to get Visual Studio Code and install that. Having said that, let's get into our Ansible demo. This is going to be a rather quick one. We're already at time, and I'm sorry about that. Whoops. Hey, I also have a GitHub repository for you guys to download and use. All right. Speaking of inventory, this is our AWS inventory. You can see that this has to end the file name with AWS EC2. I just use that as the file name. This is where you put in the plugin name. That's one I showed you at the collections list. I have all the regions that I have access to listed here. In case I want to change a region, I just have to uncomment it. And then this is the region I'm using. And then the keyed groups is how are your different instances within Ansible going to be grouped in your inventory. I want them grouped by operating system, project, and role. I want them to be shown, all the host names to be shown in my inventory as the tag name. So the name that is shown in AWS, I want that to be my host name. And my Ansible host means that I'm going to take that host name and add my domain name to it. And then special groups that I want is, hey, if I have any of these ICE versions and I have it tagged that way, I want that to be a separate group itself. So if we go in here, we have to install our whole Ansible from scratch into our new folder. So we're going to do brew install pip environment. Then we're going to do a pip environment install of Python. I want to use a specific version, so I'm going to put that at the end. Now we're going to do a pip environment install Ansible. To be able to work with ICE, we have to have the cisco.ise SDK installed. It is all one word. And I have to tell it I want it installed. And then we're going to do Paramiko is one that I use for every one of my environments. And what that does is it's a Python using SSH, so I can connect to any ICE instance that I want to through SSH using the Python that's in my environment. The James path is to allow Python to parse JSON. Amazon is so that I can read my AWS libraries. Boto 3 is a base need for the Amazon SDK. And then Boto 4, and then try this again. All right. And then if we go into our pip environment shell, this is our virtual environment that we have here on our machine, that no matter what happens to this environment, it doesn't affect the rest of our laptop at all. And we can destroy this environment, do anything that we want with it without it affecting our laptop. So I'm going to do an Ansible inventory using our plugin. And I want it to be shown in the graph, which is kind of a list format that's separated by all the different, the OS and the name and everything that you saw. All right. Now you see here, the first line is failed to locate credentials. And why is that? Well, that's because this is a different shell. The shell that we had in VSCode is different than the shell that we have on our shell, just because it's accessed differently. So it's a different shell. So we have to load our environment variables and then do our inventory. And you can see it separated everything out by project, role, and all of that. And I know that we're at time, we're about 12:06. I'm going to take it to at least 12:10, just because I want to get you guys to be able to create a playbook. But now that we have Ansible installed, we have our Ansible config file, and that tells us where everything is within our directory structure. Like our inventory is in the inventory folder. So it knows to look in the inventory folder to get all of our inventories for our hosts. The enable plugins, it does the auto plugin first, and that the auto plugin is what finds the plugin for our Ansible inventory. We're also, remember I said that if we have variables that we want to store in different file names, well, I have these files here. This is my main file for our inventory for environment variables. And I just have everything defined here. So everything here that is a key shown in blue is a variable within Ansible, and we can use that in any one of our plays, tasks, or roles. You can see here that I'm looking up the actual shell environment variable for the password to get this variable. So even within my variables, I'm not exposing my credentials out to the world. And you can separate it off by different things that you want to use and you want to do, right? And that's how the variables work as far as that goes. Let's take a look at some of the playbooks here. Now, I know we've done a lot with the network devices, so we're going to stick with network devices. You can see here that the play is create network device. I'm using that variable's main file for all my variables. But you see the host name here, I used Ansible host. Well, the reason I'm using that is we remember back in inventory, we defined Ansible host as a variable, and it says that it is the instance name plus the domain name. So that means that this is going to populate with my ice33public.icelabs.net. The ICE username, the rest of this stuff is going to get from my main variables file. I filled in all the values that I want. So if I come over here and I tell it I want to run an Ansible playbook, it's in my playbooks folder. It's done on ICE. I want to create a network device. And I press enter on that. Boom, you can see that it creates a network device. And then I have a couple of these post tasks here, which shows your network device information, and then it gives you a little message that says this. That I wanted to do just to show you why you want to do the register, a registered device when I created that. So I'm showing the results of that device. And by using those results, I was able to create this little script here that tells you what the network device name, IP address, the script, all the different information from this device that was created. So it's not just static information, it's dynamic information. You don't need to do that. You can actually go in, let's update it. See, oh, I do have it down here. I like to get results back from what I do. So this is going to be the put command for updating the network device. If you want to see that we actually do have the network device in ICE now. This is our Ansible test network device that we just put in there. So instead of create network device, we're going to update the network device. And see, now the network device has been updated. And down here, it tells you, the different tasks that have been sent and completed. Tells you how long each task took. It tells you the total time for the whole playbook to run. If we go back over here into ICE, you can see that we have updated the description of our network device. So to follow up, yeah, I do have a GitHub repository. This is the one for today's webinar. This is the direct link to it. One thing I did want to show you about that, though, is within that GitHub repository, I've got a README file, and this README file goes in depth and step by step on how to set everything up and get your virtual environment and everything like that set up for whatever you're using as it pertains to ICE, so that you can run your playbook. One last thing I did want to note, in case you didn't already know, that yesterday ICE 3.4 was released. And to learn about our APIs and anything else that you want to learn about them, just to cs.co/APIs.